Okay.
Yeah.
Okay.
I just ran a little bit.
All right. So let's talk big picture. So you got MgCO2 dot something H2O. This has to be the number of moles of water. It's the moles of water as a ratio to the moles of magnesium chloride. Big picture. You're starting off with a hydrated form of this. Okay? Why do you have to heat it up right away?
Evaporate.
Not really
Break
evaporate.
it apart.
You got to break the bonds.
Come on.
You got to put energy in to break the bonds. Okay?
Oh, okay.
Right? We're not really evaporating it because this isn't a liquid. Okay?
You're right, you're right.
Okay? This is not an aqueous solution. Hydrates just have water molecules attached to them. Okay? Ask ChatGPT. It'll verify that. Okay? So, you want to calculate the total number of moles of water lost when the sample was heated. So, if you do that, and you've got to take like the mass before, mass after, figure out how many grams of water that was lost, then you have to convert that into moles. So your answer to part 1 should be 0.103 moles of water. Okay? Now, listen to me. Notice that they've given you really good data. So when you do this conversion, when you have that precise of data, don't write this as 0.1. Okay? If they give you lots of data, you keep lots of numbers when you do the calculation. Okay? Good with it.
On an exam, would we have to go 5 sig figs since the data gives us 5 sig figs?
You don't necessarily have to go 5, but certainly you don't have 1.
Let's just keep it safe at 3.
Generally, you can't go wrong with 3. Okay? It's a good operating parameter. You generally can't go wrong with 3 unless it's a really, really wonky deal on either side of that. Okay? Now, the next thing that you need to do is figure out how many moles of magnesium chloride that you have. Okay? How many moles of magnesium chloride do you have left? So you've heated it up. So here you are in this crucible. You started off with the water and the magnesium chloride. After you heat it up, what's the only thing that's left?
Magnesium chloride.
Then you have the anhydrous magnesium chloride. Okay? Now you have the anhydrous magnesium chloride. So if you know the total mass of stuff that you started with, and you know how many grams of water you lost, the magnesium chloride has to be what's left over. So this is a ratio of moles. So you need to take the mass of magnesium chloride, okay, which is going to be 1.629 grams of magnesium chloride. So if you subtract that out, you're going to get that number.
Yep.
Molar mass of magnesium chloride is 95.3, and you get 0.0171 moles of magnesium chloride.
Yes.
Cool. Now, step back for just a second. Step back. You're trying to find this ratio of moles. Step back. Do you have more moles of water or do you have more moles of magnesium chloride?
MgCl2, so divide by that.
No, water.
Wait, what? Wait, more or less?
You have more moles of water
More, because 0.1 is greater than
or more moles of magnesium chloride.
water.
So what that tells me is the number that goes there has to be bigger than the number that goes in front of the magnesium chloride because I've got more moles of that. So are you going to take 0.0171 and divide it by 0.103 or 0.103 divided by 0.0171? The second one. And what are you going to get?
You get like 6 water.
0.103 divided by.
You get a ratio of 6 to 1. So you get 6 moles of water to every 1 mole of magnesium chloride. So the number that goes there is 6. It's a ratio of moles. It is not a ratio of mass. Okay? So moles are the great equalizer in that problem. Okay. Then it says different student heats to hydrate, uncover some of the solids patterns out. spattering will have what effect on the calculated mass of the water loss? So will the calculated mass be bigger or smaller if some of it flies out?
Bigger.
Bigger, why?
Because they'll think that the mass that fell out is water, but it's not all water.
Yeah, because if you see a bigger difference, you think, oh, I lost it all to water. But in reality, you lost some of that magnesium chloride. Okay, so on D, literally, this is the lab that you did. So you have magnesium chloride and potassium nitrate, okay? And they're mixed together. Are both of those soluble in water?
Yes.
Yeah, it's all chloride.
Because all chlorides are soluble except for
Silver and lead.
silver and lead. All nitrates are.
Soluble.
So this is what you all did. You put this in a beaker and you added water to it. Everything is going to dissolve. Everything's going to dissolve. It's all soluble. But you're told that you have silver nitrate. So here's what's important. In here you have magnesium ions, you have chloride ions, you have potassium ions, and you have nitrate ions. True?
Sure.
I'm going to add silver nitrate. What's going to make the precipitate?
Silver chloride.
So your precipitate is going to be your silver chloride. Okay, that's the lab that you all did. You filtered it out. You put it on filter paper. You found the mass, right? Remember that?
Yeah.
Those sit there and go, we never did that. Yes, you did. Okay? You might have slept since then, but you did. So here's the story. You want to describe the steps necessary to determine the mass of the silver chloride precipitate. So all you have to say is add some water, run it through, mass the filter paper. You have to have the mass of the filter paper before you do it. Run it through, collect the silver chloride, let it dry, find the mass of the silver chloride. Okay, that's all you have to say. Okay, you don't have to get into anything high tech. So now you have the mass of the silver chloride to be 5.48 grams. Okay, of silver chloride. So what you're ultimately trying to find is the moles of the magnesium chloride. So, right away, when you have the silver chloride, the grams of the silver chloride, what can you do with that?
Moles of silver chloride.
So you can get moles. So that molar mass is 143.32 grams of silver chloride for 1 mole of silver chloride. Right? True? Now, if you look at the reaction, everything in terms of this, you have magnesium chloride. This is a double displacement reaction, basically. So the magnesium chloride is reacting with the potassium nitrate to produce, that's an arrow, magnesium nitrate and 2 KCl's, right? True? Okay. So the other reaction is KCl plus silver nitrate yields AgCl. Now you have 2 reactions, and now you have 2 different mole ratios. So out of here, you have the moles of AgCl. So if you have the moles of AgCl, what could you figure out?
Moles of potassium chloride.
Moles of potassium chloride. So that's a 1-to-1 ratio. So for every 1 mole of AgCl, that reacts with 1 mole of potassium chloride. Cool. Now, you come down here, what's the ratio between potassium chloride and magnesium chloride?
2 to 1.
2 to 1. Now you can figure out, now you can come down here and go, oh, I got 2 moles of potassium chloride to every 1 mole of magnesium chloride. Now you can figure out how many moles of magnesium chloride that you have. That's the lab that you all did. Okay? Then when you get the moles, convert that into grams. Let's go home. And yes, I did have McDonald's.
Extra
You
credit.
take
Hey,
it on
that's
the
one,
McDonald's.
that's 1 point extra credit on my test.
The McDonald's cup is sitting right here.
Oh, I didn't see that. Half a point?
I mean, I guess Arby's. Mine is good.
Oh yeah, Bert Jim, I know what you like. You want the quarter pounder with fries and a Dr. Pepper, no diet.
No pickles.
Oh, yeah, of course.
Yeah, and no